এই লকডাউনের সময়ে সবকিছু থমকে থাকলেও শিক্ষার গতিকে ত্বরান্বিত করতে এক যুগান্তকারী সিদ্ধান্ত নিয়েছে ত্রিপুরা বিদ্যালয় শিক্ষা দপ্তর। এই সময়ে ছাত্রছাত্রীরা যেন ঘরে বসেই সিলেবাস অনুযায়ী পড়াশোনা চালিয়ে যেতে পারে, সেই লক্ষ্যে বিদ্যালয় শিক্ষা দপ্তর রাজ্যের অভিজ্ঞ শিক্ষক শিক্ষিকাদের দ্বারা পরিচালিত ই ক্লাসরুম সম্প্রচারের ব্যবস্থা করেছে বিভিন্ন স্থানীয় টিভি চ্যানেলের মাধ্যমে। ত্রিপুরা বিদ্যালয় শিক্ষা দপ্তর সমস্ত ছাত্রছাত্রীদের উদ্দেশ্যে আবেদন রাখছে তারা যেন এই লকডাউনের সময়ে ঘরে বসেই বিভিন্ন স্থানীয় টিভি চ্যানেলে সম্প্রচারিত এই ই ক্লাসরুমগুলির সুযোগ গ্রহণ করে। বিদ্যালয় শিক্ষা দপ্তর দ্বারা প্রচারিত ত্রিপুরা সরকার।
Again we have come to for the explanation of the chapter electricity. Today I'll discuss electricity chapter, and it is for class 10. Myself, Nabanita Chakraborty, will discuss about the physical science part. Yesterday we have explained that we have studied about various things, various topics related to electricity. In that case, I have explained about electric current, and after that you know that the different units, SI unit, which are using, we use in case of electric current. After that, we have also discussed about electric potential and potential difference, its unit, and how to measure the current and electric potential or potential difference. After that, we have also explained about Ohm's law. That means it is very important for us. That means V proportional I. We have explained very well, and after that explanation, we got the result of that from V proportional I. This relation, we have got the constant, that means the resistance, and its unit we have also explained. Today I will explain the other topics related to resistance, and in that case we have also completed yesterday various numerical examples related to that of Ohm's law and electric current, and we have done in case of potential difference, we have done everything yesterday. Today the first question which will I explain, it is that on which factors resistance of material depends on. So before going to that part, I want to show you something, that is the physical instrument. Physical science, in case of physical science, what instruments we use in practical laboratory. In your class 10 electricity chapter, there is a theory part and as well as practical part also, that means project part also. Every year we take one project or practical, 3 practicals for this practical part. In that case, students can go to the laboratory and they can see the various instruments related to that experiment. But this time, as it is everything is going to online classes, so I have taken some instruments and will give you the discussion and will discuss about that instruments to you. Because it is very important to gain the practical knowledge whenever you read or take the physics part, you say, as well as for biology part, chemistry part also. At first, here you see these things. These are called resistance, and in case of resistance, what we know about resistance is the obstacle and flow of current, and what is the instrument or device we use to measure the current. So you see, this is the ammeter. Here the range is given of the measurement, and whenever we will do the experiment or we will take the measurement, we will take the discount from that at first. After that, we will take the reading. In case of potential difference or electric potential, yesterday I have explained that we use the voltmeter that is here you see. In that case, case also the range is given and we have to find the list count at first. After that we take the readings. In that case it is positive, it is negative. In that way we use this voltmeter and ammeter to make one electric circuit whenever we do the experiment. In case of electricity chapter, one experiment every year we do one experiment, that is find the resistance from the real graph, and in that case students can see students can do that experiment in their way and by on the practical laboratory. So this time, this is here you see, this is a resistance box of 5 ohm. This is the resistance box, and here these resistances I have also shown. Now there is another thing which is very important. Here you see, the same or the better. It is very important to make one electric circuit or a closed path to flow the current. It is very important. Here you see the battery. It is also battery. And we also use the galvanometer. It is same as that of the galvanometer and the wires, which is very important to make one circuit. Wires, we use this. This is the key. Closed, open. In that way, in case of electricity, actually, if you don't know what is milliammeter, what is ammeter, or what is voltmeter, or what is galvanometer, if you have no idea about the practical things or practical these instruments, then it is very that means in that case I am giving you the some knowledge about that instruments, and you use that all the instruments in the practical work whenever the school will open. So after that that part I am going to the next topic. Resistance. What is resistance? Yesterday we have explained it very well that the unit of resistance is ohm and it is volt by ampere, and resistance is the obstacle to flow of the charge. Now this R equals to V by I. On which factors that R depends on? Actually R depends on various things, that means the length and cross-sectional area. It also depends on the nature of the material and also on temperature. Now, in case of length, what happens? If you write R greatly proportional to L, what does it mean? It means that the length, whenever the length increases, the resistance also increases, or whenever the length decreases, the resistance also decreases. That means if resistance becomes lower, that means R proportional L, that means it is directly proportional. And in case of cross-sectional area, what we can write? R is inversely proportional to the area. That means whenever the area becomes higher, that means whenever the area increases, then the resistance decreases, and whenever area is decreases, then resistance increases. In that way they are related. R proportional to L and R inversely proportional to the cross-sectional area. Now we'll explain another thing from that two equations. What we can write from this 1 and 2? L by A. Where R, there is L by A. Whenever we write this thing, that means we can know that it is directly proportional to L and inversely proportional to A. What we can write then? R equals to V into N by A. Now, the question comes, what is this? This rho. It is also constant. It says that it's the resistivity or specific resistance. In that way, you can calculate that what is the definition of rho, or that means specific resistance or resistivity, whatever you say. R proportional N, R inversely proportional A. If this combine this 1 and 2, then you get R proportional by A, and R equals to rho into N by A. Now what you can write about rho? Rho equals to R into A divided by N. In that way, we can explain about rho. One thing, what I have told yesterday, that the unit of resistance is ohm. We also can express this ohm in that way. Or you also can write this in this way, ohm. In that case, now we'll explain about the unit. What is the unit of R? The unit of R, that means resistance, is ohm. What is the unit, that is SI unit of cross-sectional area? You know that very well. Then whenever we use the area, that means we can write meter square. And the SI unit of length. What is the SI unit of length? That means meter. In that way, if we cancel this, what we get? Ohm meter. Then you also can write this ohm meter. Now, here, if the question comes, what is the unit of resistivity or specific resistance in case of that from which comes from resistance? Then you can put the unit of R, SI unit of A, and SI unit of N. After that, you calculate this ohm meter. In that way, we can explain about the unit in case of resistivity. Now, I will go to the next topic, but before that, I also want to say another thing. Whenever we can write rho equals to R into A by L, whenever A equals to 1 and L equals to 1, if I take unit measurement, then it becomes rho equals to R. In that way, you can explain. And in case of physical science or physics part, this is my suggestion that whenever you do the numerically based questions, that means whenever these type of questions you will solve, then you will practice this by writing. It's very important for you. If you write these things, that means you can do it very easily. Now, we'll explain the next topic. Before going to that, I'll explain one numerical, and by which you can understand this thing what I have done earlier it very easily. Resistance of a metal collar of length 1 meter is 26 ohm. If the diameter of collar is 3 meter, what will be the resistivity? So I have to find the value of that means specific resistance or resistivity. In case of what is given to the question, the resistance of a metal of length 1 meter is 26 ohm. That means length is given 1 meter, R equals to 26 ohm. I have to find A. You know about A whenever we say that pi r square, we use this formula. So here given the diameter of the wire. You have got the diameter of the wire and it is given that 3 meter. So what is the radius? Radius will be 3 by 2 meter. A is pi r square. What is the value of pi? It is 22 by 7. In that way, we can write area by pi r square using that pi r square 22 by 7 into 3 by 2 whole square. Now you have got this, that means meter square. Now you have to find the value of resistivity. That means rho equals to, know that R into A by L. Rho equals to R into A by L. Now put the value. It is very simple. You put the values and do the numerical at your homework copy. Everything I have given here. Then R and A. It is pi r square. Given there is the diameter is 3 meter. From that diameter you find the radius R equals to 3 by 2. Then put the value in that case. In case of this type of numericals, I have also discussed yesterday that if it is given as centimeter, then you have to change it at first at meter. That means you have to change it at SI unit. After that, you will solve the numericals. Because in same unit we have to calculate the numerical problems. In that way you can solve this. In case of other numerical, there is one example again I am explaining which is very important for you because with the theory numerical examples also are very important. When a 12 volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of resistance of the resistor. In that case, you find that the current is 2.5 milliampere. So I have to change it from milliampere to ampere at first. In that case, whenever you also take the readings in the emitter, if it is given in that means whenever we have to change at first the value at ampere. If there is reading in milliampere, we will change it to the ampere at first. It is same as a numerical example also. Given that when a 12 volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere. That means R equals to 2.5 milliampere given. And V equals to 12 volt. I have to find the value of R. So, whenever we do the numerical example, at first we want to know about on which formula it can be solved. Ohm's law. What we have learned from Ohm's law? V equals to Ri. So here you got V, you got I. That means you have to find the value of R. 2.5 milliampere, that means you can write 2.5 into 10 to the power minus 3 ampere. At first you have to change that. After that you put these values in that place. 12, that means Ri. R you have to find, and this is into 10 to the power minus 3. From that you will find the R, value of R. So in that way, at first we will to solve that numerical examples, it is very important to change the unit at first, the SI system. That if it is in milliampere, then you have to change this ampere, and the voltage also given, the resistance you have to find. So after that, you find that on which formula it is given. That means from Ohm's law you can write V equals to Ri. So you put the value of Vi and you have to find the R. In that way you can calculate the different numerical examples related to every topic. Actually I am explaining all the topics with numericals. Now the next question. It is also a very interesting one question. A wire of given material having length L and area A, length is L and area A, has a resistance of 4 ohm. What would be the resistance of another wire of same material having length L by 2 and area of cross section twice A? Here you see, at first in case 1, the length is L, the area is A, it is given. And in the second case, what is given? Length becomes L by 2 and area becomes, cross-sectional area becomes twice A. In that case, you have to find the resistance. So what we can do? This is our first thing. What we get from the formula that R equals to rho into L by A. In that numerical example, it is given that at first case LA is same, that means we can write that R1 in case of first thing, that means first case R1 equals to rho into L by A. I am giving number 1 to that equation. In second case, it has become that the length becomes L by 2 and the cross-sectional area becomes twice A. That means R2 equals to rho into, that means twice A. In that case, what we can write? 1 by 4 into rho into L by A. I am giving it number 2. So this is number 1, this is number 2. Here you see, in the first case the resistance was 4 ohm. And in the first case what we can write about that? It is 4. It's very simple. In first case the resistance is 4 ohm, it is given. Now you put the value in that case 4. That means R2 equals to 1 ohm. So in that way you can solve different examples. If it is said that the length is twice and area is half, that means you have to put at first you will do distance at case 1, and in case 2 it becomes, whenever length becomes twice L, you can write in twice L in case of L, and cross-sectional area becomes half, that means A by 2 in area, that means cross-sectional area. In that way, you can also solve this type of numericals whenever you have to find the resistance in the second case. As the material is of same, this wire is of same material, then in that way we can solve or calculate the value of R in second case. So these are the examples of the simple examples for you for class 10. You will do that whenever you read the Ohm's law and the resistance on which factors you will apply that formula. Whenever you will get the formula for resistivity, you have to do that experiment, just numericals very easily. Now, if you completed that, I am going to the next topic. In terms of physics, that means physical sense, we get two types of combination of resistances. One is, we can say that one is series combination and other is parallel combination. In this chapter, in your syllabus, what I have got that you have to read about two types of combination. One is series combination of resistors and other is parallel combination of resistors. So, what is series combination and what is parallel combination? We have to learn this at first, and after that we have to learn about the equivalent resistance from series combination of resistors and that means parallel combination. Series combination. You see, here I have taken 3 resistors of resistances R1, R2, R3. Now, if we combine these in this way, that means the nth part of the first resistor is connected to the first part of the second, and the nth part of the second is connected to the first part of the third. Then what happens? That means, in that way, if we consider that the nth part of first resistance is connected to the first part of the second, and the nth part of the second is connected to the first part of the third. Then this type of combination is called series combination. Here you see, what I have given here. The 3 resistors R1, R2, R3. And the potential difference is V1, V2, V3 I have given here. The current I is passing through it. In that case, what we can write that the N part of the first resistor is connected to the first part of the second, and the N part of the second, that means, is connected to the first part of the third. That means they are connected one by one. That means one to another, each one by one in that way. This type of combination is known as series combination. In that case, if we use another resistance R to replace these resistors, 1, 2, that means here 2, 3, I have given 3. You take number of resistances here. If you use such type of resistor, that is R, such that these resistances can be replaced by that resistor, that means which is R, then this resistance is called the equivalent resistance. That means if we put that here, it is directly as R. Then if it is called equivalent resistance, and we have to find the value of equivalent resistance in case of series combination. Then what we will do? You see, what we get from Ohm's law? We can write that V equals to Ri. It gets from we get from it from Ohm's law. In that case, whenever we are using series combination, we are explaining about series combination, the total potential difference V equals to, we can write V1 plus V2 plus V3. Here, V1 plus V2 plus V3. And from Ohm's law, we already know that V equals to Ri. So what we can write about that? Equals to R1I plus R2I plus R3I. I is constant. Here I is passing through that, and the potential difference is the combination V equals to V1 plus V2 plus V3. So if we take in that way R1 plus R2 plus R3, I cancel. Then what we can write? We can write that R equals to R1 plus R2 plus R3 in case of series combination. So for finding the equivalent resistance, so we have written written here that Rs equals to R1 plus R2 plus R3. This is very important for your physical science part, and you will read that very carefully, that how to solve this numerically, and what will do so many numerical examples related to that series combination. So we will now explain about one numerical related to that, because without practical example, or without that means whenever I have seen that all the things practically, it is very easy to learn with manual, and it is very easy whenever you see the resistances. Without that, if you don't know about what is resistance, if you think that resistance is a very big thing, no, it's not. You have the idea, practical idea about whenever we read about physics, chemistry, biology, the science subjects, we have to have the practical idea about everything, every topic, every point. We have to know the things about these things practically. So, in that case, we have calculated the series combination, and in case of equivalent resistance, Rs equals to R1 plus R2 plus R3. Now, we are going to the next point. A battery of 9 volts is connected in series with resistors 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm. How much current would flow through 12 ohm resistor? That means all the resistors you have to find at first the equivalent resistance. That means there are a number of resistors are given, 0.2, 0.3, 0.4, 0.5 and 12. So what will you do? First question, the question is a battery of 9 volt is connected in series with resistors. That means I have to find first R. 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12 ohm. 3 to 5, 4, 9. 13.4 ohm. And V is given. What is the value of V? It is 9 volt. So, whenever number of resistors are given, and you don't know about the what is the equivalent resistance, so it is in a series combination, then you what we have got in but from our formula, we also with that Rs equals to R1 plus R2 plus R3. So apply this formula and find the equivalent resistance. If the resistance in series combination is right here, and V equals to 9 volt is also given, so you have to find only the current. What is the question? How much current would flow through these resistors? What we know? V equals to Ri. You know V R, that means I equals to V by R. 9 by 13.4. Now take your homework copy and do this. It's very easy. 90 by 134, divide this and you will get 0.67. I think the result will come this type of result in the decimal system. So first learn how to write about the series combination, equivalent resistance of series combination, and after that here it is given V, and if I is given, then you also apply same formula and you will place the value of R and I and you will get V. In that way we can solve this type of simple numericals. Now we are going to the next point. Series combination, I would have completed. Now we are going to know about parallel combination. What is parallel combination? Again, I am taking the resistance. In that case, in case of parallel combination, all the first point will connect in one point and all the endpoint will connect at other points. That means I am giving the diagram here. Here, R1, R2, R3 are the resistances, that means resistors, heavy resistors R1, R2, R3. 3 resistors I have applied here. The current is I1, I2, I3 and the potential difference V is constant. In that case, what happens? You see, here all the points are connected to one point and all the other points are connected to another point. So, such type of combination where the first point is connected to that point and all the end point is connected to that point, such type of combination is known as parallel combination. In case of parallel combination, what we can write? We can write about I equals to I1 plus I2 plus I3. And what we know about equivalent resistance, that it is the type of resistance by which you can replace by these resistors, these resistances. In that case, from Ohm's law, we know that V equals to Ri. That means I equals to what we can write V by R. Now, if I put the values here, V by R equals to V by R1 plus V by R2 plus V by R3, or V by R equals to V 1 by R1 plus 1 by R2 plus 1 by R3. Cancel V. That is what we can write about parallel combination, that 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the formula for equivalent resistance of parallel combination. In case of parallel combination, we can also write it as RP. 1 by RP equals to show that parallel combination, I have written that 1 by R1 plus 1 by R2 plus 1 by R3. In that way, you can explain about the equivalent resistance of parallel combination. Now, we will do one numerical example related to that. It is very important. This numerical, if you do every numerical at every topic, then it will be very easy for you to learn about every numerical that means calculations. One question is given here. How many 176 ohm resistors is connected in parallel are required to carry 5 ampere current on a 220 volt line? It's very easy. We apply the formula for at first I know that formula 1 by R equals 1 by R1 plus 1 by R2 plus 1 by R3. That means 1 by here number of resistors is not given. So you can use any number of resistors here, and you have to find the how many, that means number of resistors you have to find. In that way, what we will do now, we will solving this. At first, you see G equals to 220 volt and I equals to 5 ampere. R equals to, that means we know that V by I. How it comes? V equals to Ri, that means R equals to V by I. Now 220 by 5, that means 44 ohm. In that way, we are getting the value of R. Now I have to find how many, that means 1 by 44 equals to 1 by 176 plus 1 by 176 plus 1 by 170 plus n times. That means you don't know how many. That means you have to find the value of n. So what we can write? One 76 by 44. That means 4 numbers of resistors is connected in parallel way to get the 5 ampere current on the 220 volt line. In that way, you can solve that type of numericals related to series and parallel combination. So we will complete this and I will go to the next topic now. Next, what is your topic? This everything is given. Heating effect of electric current. This is the I think that I'm going to the last slide. Heating effect of electric current. In that case, what we can say, whenever the heat production of heat, that means heat produced, if we express this by H, we know that it is I square RT. H equals to I square RT. Now there are some questions which I have to explain with this. Before going to that, I want to explain something with you. And one question, it is very important. What are the special features of a heating air? Whenever you will read about the topics related to that chapter, you have to read every short questions, that means 1 mark questions, very carefully. That means you have to read the whole chapter. And in that case, I am explaining some short questions which are very important. What are the special features of a heating air? That means I will go to that topic now. And in that case, another question, what happens to the resistance of the air if it is made of thinner? You already know, and I have explained that R proportional L. So you can say what will be the answer for that. R proportional L, that means whenever R, that means L increases, that means R also increases. In the next case, in series combination, which remains constant, current or voltage? I have already discussed earlier. That means in series combination, we get G equals to V1 plus V2 plus V2. That means current I is constant. You read carefully, and after that, another question. It is also very important. That means heat production, it is related to that. Okay, I will explain this at first. H, what we can write about H? V into I into 3. What is the value of V? That means we can write it as Ri. That means I square R. In that way, we can explain about the Joule's heating effect, law of Joule heating effect. And after that, actually time is going to the end, so I am just giving one, just I am explaining very quickly. That means practical application of heating effect of electric current. In that case, we get so many examples, practical examples, that is electric heater, fuse, electric bulb, you use different things you use in case of that. After that, we are going about to know what is electric power. In that case, power, what we can write about power? We can write that in case of electric power, P equals to V into I. Now, what is the value of V? R into I. That means you can write that P equals to I square R. We also can apply that rule that V into as V equals to Ri, that means I equals to V by R. That means I equals to V by R. That means V square by R. So whenever we'll try to whenever we'll solve the numerical examples, we can use this formula also, V square by R, whenever it is given V and R, and we also apply this P equals to I square R. In that case, in case of electric power, there is one SI unit, and this SI unit is watt. What is now this question comes, what is the SI unit of electric power? In that case, you can say that it is watt, and in case of power, we can write V into I, that means we put the value Ri, that means it I square R. That means if we put the value of V, then we get V square by R. In that way, electric power, you also can solve it. And another thing, in your syllabus, I think there is the commercial unit of electric energy. In that case, commercial unit is very important for you. 1 kilowatt hour. You must read it, must learn it. That's still very simple. Numerical, some short type questions. You must read. In that way, you complete the total chapter. That means at first you have to learn about the electric current, then electric potential difference, then about the electric the circuit diagram, and what things we can use to make one circuit, a closed path for passing of current, electric circuit diagram. You learn it very well, and after that you will come to Ohm's law. From Ohm's law, you must learn the statement, and how R comes, that means resistance, the constant comes, that means the unit of all the things, that means current, potential difference, and that from Ohm's law, whenever you get the resistance, its unit is, you have to read. After that, you will come to the next. That means it is very easily you can read. After that, you will on which factors resistance depends on, and you will learn about resistivity, specific resistance, its unit. It's very important. And after that, you will go to the combination of resistors. In that case, you will get series combination, parallel combination. In case of series combination, you will get that. The formula for Rs is equals to R1 plus R2 plus R3, and in parallel combination it is 1 by R2 equals to 1 by R1 plus 1 by R2 plus 1 by R3. And after that you will have to find the equivalent resistance. This calculation will do numerical and by your own, so that you can do that very easily. After that you will go to the point heating effect of that is practical examples of heating effect, and after that you will learn about power and the commercial unit of electric energy. This is all about the chapter electricity. As I have in earlier session, I have discussed everything about light part, and now in that session I am explaining about the electricity. After that, if I have class, then I will explain about magnet. It is the next chapter. So before going to that, I want to complete the whole chapter of electricity. So in that case, about power, what I can say. Some important questions. What I'm giving you one thing. You have to read this type of questions, that what is fuse and why it is very important. You read this very well. Then why is that Einstein used almost exclusively for filament of an electric lamp. This type of questions you must read because the pure tungsten has a high resistivity and its high melting point. In that way, you can read all the things in that related to that chapter. And another important question, it is very important. Why are coils of electric heaters and electric irons made of an alloy rather than a pure metal? So what are the things in case of alloy, the resistivity, you will explain about resistivity in that case. So explain with that questions properly. And as you are learning everything nowadays from home, that means an online process, so you make proper notes, that means using your textbook such that you make a very good answer, very good answer in case of physical science. And now I'm doing one thing. Again, another question I have to explain because without explanation of this thing, no numerical can be solved by you. And electric bulb is connected to a 220 volt generator. The current is 0.50 ampere. What is the power of the bulb? I have to do two questions related to electric power and electrical energy because these two are also important for you. So what is given? An electric bulb is connected to a 220 volt generator. That means V is given 220 volt. And the current is 0.50 ampere. 0.50 ampere. Now, how we will calculate the power? You know the formula very well. E equals to V into I. That means you put the value of V, you put the value of I. That means do at your homework copy. It is very simple. 220 into 0.50. Do this. Then another question, it is also very important. An electric refrigerator rated 400 watt operates 8 hours per day. What is cost of energy to operate it for 30 days at rupees 3 per kilowatt hour? That means at first, whenever we discuss about electrical energy, what we will say? Here given that the refrigerator rated 400 watt, the power is given, and it is operating 8 hours per day, and you have to find the cost of energy for 30 days at rupees 3 per kilowatt. Then at first you have to find the total energy. Total energy the given I have, that means for 30 days. Just I am giving you the how to solve this. That means total energy what will get 400 into 8 into 30 days. That means 96,000 watt. That means 240 and 4. 96,000 watt. That means 96,096 kilowatt. That means you can write that, and after that you have to find kilowatt. 96,000. That means 96 kilowatt hour. In that way, after that, the cost of energy you have to find. That means rupees 3. That means 96 into 3. In that way, you can do that. In case of electrical commercial unit, what you get, that is the unit is kilowatt hour. So it must apply unit whenever you will do the physical numericals related to physics. It is very important to apply the units also. In that way, we will explain that time is very short. We have to explain a key topic in case of electricity, and I think you will read it very properly and make paper notes and do that very well. So, time is over. Then this, thank you for today.
এই লকডাউনের সময়ে সবকিছু থমকে থাকলেও শিক্ষার গতিকে ত্বরান্বিত করতে এক যুগান্তকারী সিদ্ধান্ত নিয়েছে ত্রিপুরা বিদ্যালয় শিক্ষা দপ্তর। এই সময়ে ছাত্রছাত্রীরা যেন ঘরে বসেই সিলেবাস অনুযায়ী পড়াশোনা চালিয়ে যেতে পারে, সেই লক্ষ্যে বিদ্যালয় শিক্ষা দপ্তর রাজ্যের অভিজ্ঞ শিক্ষক শিক্ষিকাদের দ্বারা পরিচালিত ই ক্লাসরুম সম্প্রচারের ব্যবস্থা করেছে বিভিন্ন স্থানীয় টিভি চ্যানেলের মাধ্যমে। ত্রিপুরা বিদ্যালয় শিক্ষা দপ্তর সমস্ত ছাত্রছাত্রীদের উদ্দেশ্যে আবেদন রাখছে তারা যেন এই লকডাউনের সময়ে ঘরে বসেই বিভিন্ন স্থানীয় টিভি চ্যানেলে সম্প্রচারিত এই ই ক্লাসরুমগুলির সুযোগ গ্রহণ করে। বিদ্যালয় শিক্ষা দপ্তর দ্বারা প্রচারিত ত্রিপুরা সরকার।